We're now going to continue our coverage of the ThreadJoinTest case study, focusing on how to apply Java functional programming features and threads together. In particular, in this part of the lesson, we'll show how to create, start, process, and join Java thread objects using functional programming features, such as lambda expressions, method references, and functional interfaces. We'll begin this lesson by giving an overview of the concurrency model used to implement the ThreadJoinTest case study. This case study showcases functional programming features in the context of Java thread objects. In particular, the run method in the ThreadJoinTest class creates a list of Java thread objects, and then it starts those thread objects and waits for them to complete. Each of these Java thread objects searches for barred phrases concurrently. We use Java platform thread objects in this case study, though it should be straightforward to modify it to use Java virtual threads instead. This application applies a thread per work of Shakespeare concurrency model, where each work of Shakespeare, such as Hamlet or Julius Caesar, Macbeth or King Lear, and so on, is associated with the particular thread that looks for the barred quotes in that particular work of Shakespeare. This model scales quite well due to the limits on the number of works of Shakespeare. There's only 37 or 38 of them. Naturally, if we had millions and millions of works to search, we might need to consider either a different concurrency model, such as a thread pool, or switch over and use Java virtual threads instead of using Java platform threads. A snippet of the output from the ThreadJoinTest program appears on this slide. For example, a famous bard quote like, a horse, my kingdom for a horse," is shown to appear at a particular character offset in the King Richard III play. This output also displays the ID for each thread that found a match, demonstrating once again the embarrassingly parallel design, where each thread searches for barred phrases in each work of Shakespeare in a way that has no dependencies whatsoever on any other threads that are searching for barred phrases in any other works of Shakespeare in parallel. We'll now show how the ThreadJoinTest class creates and starts Java thread objects. The ThreadJoinTest run method starts thread objects to perform the concurrent barred searches on works of Shakespeare. These thread objects are created via the makeThreads method called in run. MakeThread applies the factory method pattern from the Gang of Four book to create a list of worker thread objects. A method reference to the process input method is passed as a parameter to make threads. This method searches for barred phrases in a single work of William Shakespeare. We'll examine the process input method implementation shortly. The makeThreads factory method expects a functional parameter. The use of this functional interface as a parameter makes it simple to change the function passed to the makeThreads factory method if the need arises. We'll now walk through the implementation of the makeThreads factory method, which applies its function parameter to create a runnable for a thread. This generic factory method creates a list of thread objects that will be returned to the caller, started, and then joined when their processing is done. The input list parameter to the makeThreads factory method contains a list of items to process. For example, each item could be a work of Shakespeare. The task parameter that's passed to the makeThreads factory method is bound to the function to perform on each input element. For example, search for barred phrases. The makeThreads method begins by creating an empty list of thread objects. It then iterates through the input list and creates a new thread for each element. The task function parameter is applied to create a runnable that provides the computation for each of the thread objects. Each new thread object that's created with that runnable passed from thread apply is then added to the list of thread objects. And finally, the list of thread objects is returned to the caller. In this case, the calling method is the run method defined in the ThreadJoinTest class, which uses the forEach method and a method reference to start all the thread objects returned from the makeThreads factory method. Each started thread then searches for barred phrases in its work of Shakespeare. Moreover, each call to thread start creates a new platform thread object that has its own runtime stack to perform the computations concurrently. We'll now turn our attention to the ThreadJoinTest class and how it processes and joins Java thread objects. We'll focus on the process input method, which, as you may recall, was passed earlier to the makeThreads factory method, which bound it to a thread object for each work of Shakespeare. Each thread object was then started via the forEach method and the thread start method reference. Once the thread is started, process input runs, and it searches its input parameter to identify all the occurrences of barred phrases it's been told to find. The input parameter contains a given work of Shakespeare, and we use that work of Shakespeare along with the getTitleHelper method to extract the title from the work using Java regular expressions. At this point, the process input method uses a Java forEach loop to iterate through all the barred phrases to search for. It uses a nested for loop, which calls the indexOf method on the input string to search to see how many times a phrase appears in the input data, if at all. In this case, if the return value from index of is not equal to -1, that indicates a match. Whenever a match occurs, it's displayed to the standard output. The for loop then updates the offset variable to see if there are any more matches of the phrase in the input string. And this continues until there are no more matches and no more phrases. Let's now turn our attention back to the run method in the ThreadJoinTest class. After starting all the worker threads, the run method waits for all the worker thread objects to finish by using a for each method on the worker threads list and a method reference to the ThreadJoin method. As we've discussed before, ThreadJoin provides a simple form of barrier synchronization. The run method in ThreadJoinTest uses this join method in the context of a for each method, which waits for all the started threads to finish their processing before continuing on in the flow of control after the call to for each with ThreadJoin passed as a parameter. For this type of embarrassingly parallel program, no other Java synchronizers are needed. By the way, note how we wrap the ThreadJoin method inside the rethrow consumer adapter function. This particular function is used to convert a checked exception, such as the interrupted exception that ThreadJoin can throw, to an unchecked or runtime exception. You can learn more about this particular technique at the link at the bottom of the slide. So that's the end of the second part of our lesson that shows how to apply Java functional programming features and Java threads together in the context of the ThreadJoinTest case study.